All right, so you've had a little bit of time to start working on these. Let's see how you're doing. Hopefully, you notice the pattern. We want to predict what the next three expressions will be and their values. So, um, let's do this. So that I don't call on the same people all the time, what I'll do a lot of times is use a random number generator on my calculator to randomly call on people. And let's see. Bella, which desk are you in? You're in desk 14? Okay. So it's 1 to 14. All right, desk 1. So, and this is also when I start learning names and stuff. So I don't remember your name. Please tell me. Ben. Okay. So what do you think was the next one in the pattern?
The answer or just the next one?
The whole thing.
12,345 times 8 plus 5.
So 12,345 times what?
8 plus 5.
And your predicted answer?
98,765.
98,765. Thank you very much. Desk 6. Natalie, is that you? All right. Tell me, what was your prediction?
1,200.
I'm sorry?
1,200. Oh, sorry, 12,345 times.
Wait, the next one down.
Oh, 12,300.
It gets hard when you
23,456 times 8 plus 6.
plus 6 is
9,900.
all right. Let her answer.
987,066.
That wouldn't follow the same pattern. Help her out. Yeah.
So the answer, I got the same equation answer, but for the answer, I got 987,654.
Yeah, 987,654. And it starts being really helpful if you put commas in to help you see where the break is between those. Interestingly enough, by the way, just so you know more things than you knew when you walked in the door, in many other countries, they use dots instead of commas. And you're like, well, wait a minute, then how do they do decimals? They use commas for decimals. It's very interesting the first time you see that. You're like, wait a minute, this has multiple decimals in it. And it's just a different way of doing it. All right. So let's see. That was desk 4. Tell me your name, please. Evan. All right. So tell me about it, Evan.
I did 123,000. 4,567.
All right. So that's 1,234,567
Times 8 plus 7
plus 7, and you got
equals 9.
9 million. Yep.
87, 6,
876,000. 543. Thank you. Yeah, it gets difficult sometimes to say these. All right, let's see. Maybe we'll get somebody with a higher number. Nope. You're it, Cooper.
Wait, it's 4? I only did 3.
Oh, it only asked for 3? Oh.
I didn't do it the next thing though. I forgot how to do actions in the previous thing. I can only do it.
It's
if it's
what does it say to do? Use the calculator on your iPad.
I don't know the formula.
Oh, there's no.
Just divide
All right,
by
shh, 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 shh. There is no formula. It's just that a fraction is a division. So on your iPad, do 1 divided by 9. And then what do you get?
0.1 or approximately 0.11.
Wait a minute, 0.11,
11, like approximately.
1. It just keeps going forever and ever, right? Okay. All right. Why is this only giving me tiny numbers? Who's in desk 11? All right. Tell me about it. What about 2 9ths?
Yeah, I forgot the same thing.
I'm sorry?
I forgot how to do it too.
All right, we'll do it real quickly now. So remember that a fraction is a division problem. So what did you get when you did 2 divided by 9? So do you have a you guys have, do you have a calculator on your iPad?
I just use the calculator website.
You just used a calculator website
There should be an app that's like automatically.
that's already built in?
Yeah.
I don't have
Oh,
that.
okay.
I tell you what, to speed this up, let me just say 2 9ths is going to be 0.2222, yada yada yada. 3 9ths is 0.3333, yada yada yada. And 4 9ths is 0.4444, etc., etc., etc. So remember that to change any fraction into a decimal, you divide. And I didn't want you to have to do it by hand. All right, so let's turn it over to the back or to page 2. Decimals like 0.3333, etc., 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 and others you found in part 1 are called repeating decimals because the digits continue infinitely. Instead of using ... to show the numbers repeat, mathematicians write a bar over the digits like this. 0.3 and you put a bar over it. Have you guys seen that before? Yes? Okay, so you have seen that before. So it is standard to write the repeating digit just once. So when you have 0.22222, you write 0.2 repeating. You don't write 0.22 and then decide, oh yeah, it repeats. Okay? So this is the standard way to write this. So list the next 5 fractions in the sequence and predict how they will look if they're written as decimals. So that means that 5 9ths, we would expect it to be what? 0.5 repeating. 6 9ths, we would predict that to be,
6 repeater.
yeah, 0.6 repeating. 7 9ths, What would we pick? Yes.
0.7 repeating.
Yeah, 0.7 repeating. 8/9. What would we predict for this? 0.8 repeating. And then 9/9, what would we predict? Not what is the answer your calculator gives, but what would we predict? Yes, sir.
1.
No, I didn't ask that question. I said, what does our pattern predict? You got to answer my question, Bella. Or Ella, sorry. Emma. Sorry, 4 letters, starts with an E, ends in an A. I apologize.
The pattern would be 0.9.
Would be 0.9 repeating. It turns out, and I'm not going to take the time to do this today, but I can prove to you that 0.9 repeating is actually equal to 1. And you're like, wait a minute. Remember, the 0.9 repeating means it repeats infinitely. It turns out that it is actually equal to 1, but we won't do that today. All right. What doesn't seem to follow the pattern? The 9/9. Right? The first 4 match your prediction. So the first 4 match, but the last one does not. The first 4 of those match, but then the last one, not so much. All right, let's move on. Decimal numbers that only have a finite number. It's really interesting. A lot of times students know the word infinite, but don't know the word finite. Infinite means it has no limit. Finite means it has a limit. The IN at the front means not finite. It's literally what it means. So, decimal numbers that only have a finite number of digits, like 2.173 and 0.04, are called terminating decimals. When you terminate something, you end it. It is the end. So, for example, if you go on a trip someplace and you fly, what you go into the building is called the airport terminal. It's the end of your flight. You get off at the terminal. Some fractions can be written as terminating decimals, like 1/2 is 0.5, 3/4 is 0.75. And the question is, do the decimal equivalents of the numbers below terminate or repeat? Be ready to justify your answer. Well, the first 2 are really stinking easy because they're written as a decimal. Does this terminate or not? Yeah. That terminates. 0.6. Does it terminate? Yes. If we're doing 5/6, let's do the division. Let's do it by hand. See, 6 doesn't go into 5, but 6 does go into 50. How many times does 6 go into 50? How many? 6 into 50?
It's like 70.
8.
8 times 6 is 48. That's as close as we're going to get. See, that's 20. 6 into 20 goes 3 times. Oh, and that's going to be 20, and it's going to keep going over and over and over again, isn't it? Does the 8 repeat in this one? No. It's 0.83 repeating. This repeats. What about 4?
Terminates.
Yeah, it terminates. Two fifths. Anybody know what that is as a decimal just right off the top of their head? Yes, ma'am. 0.4. And by the way, one of the easiest ways to do that is to go, well, that's 4/10, right? Just doubling them both. And this is 0.4. The 4 is in the tenths place. So this terminates. And what about negative 0.33? Does it terminate or repeat? It terminates. They don't have the repeating bar above it to say that that keeps going forever and ever. Amen. All right, page 3. One of the things that your book likes to do, and I think it's a good practice, is to represent multiple numbers in lots of different ways. So the 5/6 can be written as the decimal 0.83, where the 3 is repeating. You can also represent it in geometrically or graphically with a diagram. A couple of different ways. You could draw 6 of something and shade 5 of them in, or you could divide up something into 6 equal pieces and divide them or shade 5 of those in. You may have mostly done like circles. Did you do a lot of this before? You divide this into 5 equal pieces, which I find to be very difficult. My 5 pieces are never quite equal. That's okay. And you shade. Oh, but this was 5/6. Duh. That I can do. Because I'm good at making it into 1/3, and then I'll just divide that up. So I've shaded in 5/6 of a full object, or you can shade 5 out of a set of 6. So portions can be represented in words such as 5/6 and as percents, which are portions of 100. This is called a portions web. On your homework tonight, they're going to ask you to do some of these. So the portions web, you have to have a fraction, a decimal, a percent, and either write it out in words or as a picture in the middle. So for 2/3, we're going to draw a portions web for that. Let me leave that up here. So we'll put 2/3 up here at the top. Let's figure out what the decimal is for that by dividing. 3 divided into 2 goes 0. That'll go 6 times, which is 18, and we get 2. And we already know, okay, we already recognize that. That's going to happen over and over and over again. So the decimal is 0.6 repeating. Now, as a percent, what is the easiest way to change a decimal into percent? Yes, sir.
You move it to the right 2 times.
Who's it?
The decimal, like, to the right.
Okay, move the decimal to the right 2 places. So if we did that, this would be 66.6 repeating percent. And it's your choice for the middle. You can either write the word 2/3, or you can do a drawing that shows 2/3. Your choice. I'm going to draw 2/3. And there's different ways that you could draw 2/3. It's entirely up to you. And then for each part, determine if the decimal representation is terminating or repeating. This is a repeating decimal. All right. Try this with 5/4. Some of you have already started, overachievers. See what you can get on this. Yes, ma'am.
1.35.
Oh, I was letting everyone work.
Look at big football.
Sit there and look smug. Or you could, look around and see if anybody needs help. All right, so what were you saying the decimal was?
1.35.
1.25? Yes. Very nice. Somebody else tell me, repeating or terminating?
Terminating.
Terminating. All right, let's change that into a percent. Someone who I haven't talked to today. Yes, sir. 125%. Now, occasionally I have students who are like, this is hard to draw. You can write out 5/4 if you want, but if you want 5/4, what you could do is draw 2 circles, break them both into fourths, and color in 5 of the pieces. That would be one way to do it. Are there any questions on this? Okay. I'm going to hand back your papers. I just did a very quick check of them. Please just take yours and pass the rest back. I want to point out a couple of things to everybody. Read the directions. Some of you did not read and follow the directions. I was very nice today about it. Oh, sorry, one more. I was very nice today about it. In the future, I will not be. On the first section, it said find the perimeter and the area. Some of you only found the perimeter. You go straight to math hell for that. Yes, sir.
Is there like an easy way to solve 5
What do you mean solve it? To find the decimal, you always divide. That is the only way. Okay? Alright, let's go over the answers to these. And you can see how you did. This material will be on a quiz next week. Okay? Oh, the other thing is, and I wrote it on one person's, and then I was like, I'm gonna have to write it on 7 or 8 people's. I expect to see your work. So, like on number 1, when you're finding the area, I expect you to write 1/2 of 7.5 times 4. And yes, I expect you to be able to do that without a calculator. Okay? Alright, so for number 1, the perimeter is 18.5 inches. And the area is 15 of you left the units off on all of them. That will also lose you points. Part B, the perimeter is 61.4 centimeters, and the area is 210 square centimeters. Part C, the perimeter is 22 yards, and the area is 21 square yards. Number 22 for part A, it turns out that the mean is 79. For part B, it's 1.5 cats. Part C, it's 23 minutes. On the back, quickly, A, perimeter is 18, area is 9. B, the perimeter is 24 feet, and the area is 28 square feet. C, the perimeter is 46 centimeters, and the area is 120 square centimeters. Number 4 is 82. Number 5, it's going to cost $10.50. And number 6, the answer is free. All right, the bell's going to ring in less than a minute, but if you have a quick question, I'll be happy to answer it. Okay. Your assignment tonight is in the book. So you'll do that on your own paper. Most of your assignments in this class will be out of the book. Remember, you can access the book through Google Classroom, which I need to get you set up on. Y'all have a terrific weekend. Pardon? The homework is stuff like today's one.
No, it's not.
It's in Rimweb. It's also on my calendar on Google Classroom. Johnny, did you get the code? Excellent. Thank you, you too, ma'am. Hey, Ben. Hello. How are you, Grace? Doing okay, thank you. Can I help you find something? Science is in building 2, which is that way. You're welcome. How are you today? What's up, Sebastian? How are you today? Christina?
I know.
Good morning. desk is.
Oh,
Four.
I
So
forgot.
you're in 4. It's also pretty easy because if you look at that, that's also where your desk is.
Oh.
Yeah.
Well, I forgot Sebastian. Okay?
It's been 2 days
Can I not forget?
and we've done it twice.
You forgot Sebastian? He's right there. How can I forget it?
Comma.
Oh, I forgot.
It wasn't, I didn't
Sebastian.
really hear his face.
Actually, it makes me really happy that you knew that you should put a comma in to fix that.
English is my strong suit. I'm so hungry.
All right, so that's everybody is here.
April 3.
Okay. So on Fridays, what's going to happen most of the time is that I'll come around and check your homework as quickly as I can while you're doing something else. If we have a new lesson, I should say. If we have a new lesson on Friday, what typically is going to happen, I think, is that I'll zip around and check homework real quick. But while I'm doing that today, I want you to be reading over today's notes. Okay? We will we'll do the notes first, and then we'll do the homework. If we don't have time to get to the homework, we'll do it on Monday. Okay? Fridays are just insanely short. And so, thank you. Thank you, Adam. There are 2. There's that one, and then there's Carl back there. Carl is the best pencil sharpener in the universe. But it's a little weird to use. So squeeze the 2 black things together and pull them to the left.
I'm struggling. I'll just use that one.
No, this is way better. All right, so you squeeze these 2 together and pull it to the left. Now squeeze them together again and shove your pencil in. Now, you don't have to push this, just hold on there and turn. And when it gets, just keep going. When it gets easy again, it's perfectly sharpened. Thank you, ma'am. You feel it suddenly get really loose?
Whoa. That's cool.
Isn't that a good sharpener? We're supposed to go through. You're 17. In class, I was like, 1 through 17. I told you guys in class, 1 through 17. We had a whole discussion, and I said, I need to change that, and I changed it. Did you do the same thing, do 1 through 7? Let me see what you did, please. Okay.
Yeah, it makes good sense.
Or whatever.
Yeah.
So now I just take this.
Graph paper, you draw straight lines.
Well, I was like, I might as well just put it on there, just so that it's graph paper letters.
Yeah.
And yeah, I'm bad at drawing straight lines. So,
I'm not always very good either. All right, so as I said, we'll start with the homework. I'm sorry, we'll start with the lesson. So if you'll have that out. What the heck?